Okay, today I'm going to talk about how to do real-time log stream analysis with some open source tools. So first, let's take a look of these logs. And log is one of the key pillar of the observability. You know, the logs, metrics, and tracing, right? So logs are critical for your observability because it provides the detailed information about what happened in your system. So you can use log for debugging, for performance monitor, for security monitoring, or audit, right? So this is a sample of the logs. The topic I'm going to talk about today is about the real-time log analysis, right? What is real-time log analysis? So this is a log analysis data flow. Say we start with data collector, and we collect all the logs from the servers or devices, and we store the log somewhere, and then we can do some log query, and based on the query result of these logs, we can visualize them or we can send alert, right? This is an end-to-end flow. You can see it's actually a typical data processing flow, right? Even if it's not log, it's just a regular data project. You will have the data collection, storage, query, visualization. So it's quite similar like any other data analysis flow, right? Specifically for log analysis, actually there are a lot of very mature tools like Splunk, Datadog, SomaLogic, right, Elastic, right. There are a lot of vendors and tools you can use to do the log analysis. Why? So why I'm talking about log analysis today? Actually, the existing tools, there are limitations of these log analysis tools. So most of these log analysis tools is actually based on the search. So what does it mean, the search? So the search-based architecture is actually just when you get a log event, we do some tokenization. So we turn the log data into word, and we build some inverted index. And then we can search because there's a large amount of logs. Based on this inverted index, you can search if specific word happen in some specific event, right? So this is the search-based architecture. There is a limitation for this search-based architecture is that because you need to save the event into index, and the index is event actually take time. Before making a event searchable, you need to build the index. So that means usually when you get a new event, it's not immediately searchable. It has to be wait to be the event to be tokenized, be waiting for the index to be built, and then it is searchable. So that means it's not actually a real time stuff. So in some case, like a security monitor, I want to know what happened when some error happens. I want to be notified immediately. So in this case, actually, the search-based architecture based on those inverted index, right? The search-based architecture is actually not the best solution because it takes time to your new data to be searchable, right? So that is why we want to introduce you this real-time monitor, real-time log analysis. That means as soon as this something happens here, so say here's the error log, right? As soon as this error happens, we have a streaming processing tools that immediately identify this event. It's a error, and then we take action immediately. So that's the streaming processing. So I'll give you some example in the follow-up sections. So what I'm going to talk about today is actually based on this open source streaming data engine called Proton. So Proton is actually like a streaming database. It's a combination of like Kafka, Flink, and ClearHouse. So the whole architecture is it's actually a two system. If you have a read a book by Daniel Kahneman, the thinking fast and slow, right? So the human brain, it means the human brain has two systems, the type 1 and type 2, right? Type 1 is fast, making immediately instinct actions, right? And type 2 is actually do analytic, more thorough thinking. So the problem is actually the similar design, right? We have two storage system. The first is the streaming storage. It's actually a pen-only log, similar like Kafka, but it's not Kafka, but it's similar as Kafka. It's streaming-only system, so when it's a pen-only log, so when the new data is coming, it immediately know these actions. And there's a historic storage is actually based on the ClearHouse. So you can run the historical analysis because ClearHouse is based on the column storage. It can analyze large amount of data very quickly. And then we have a unified query processing engine based on streaming SQL, right? This will do the incremental SQL processing. So once there's new data coming into the stream storage, we actually can immediately process this data in a streaming way and send the result to the user. So let's start with some real examples, right? So there's several solutions you can follow. So the first one is actually based on this Firebase, Kafka, and Proton architecture. So the first we have logs, and we collect those logs using Firebase. Firebase is actually a Golang-based log shipper that built by it's part of the Elastic Stack. It can effectively collecting the log and send to some other targets. So in this case, we send data to Kafka, and then we use Proton to read the external logs, the external streams. So Proton read the stream from Kafka, and then we can do the data analysis, the log analysis, because once the new logs come in, it's the log bit, the Firebase would read it, so just like a tail, and the new data sent to Kafka, and this event will be processed by Proton. Okay, so let's go to the demo part. I will show you the demo. Okay, here is the demo code. It's actually on the GitHub. You can later on can share that. So the first, let's take a look at this Firebase deployment. So we have Proton here. It's just you just create a Proton, and then we have Kafka here. It's actually I'm actually running a Redpanda. So because Redpanda is a fully compatible with Kafka, and it has a better performance in C++ base. And then here we do have some like health check stuff to make sure each service is started successfully here. And then we have this Firebase, right? The Firebase is so in this case we actually mount the Proton server log, right? The log I just showed, and to the volumes. The beats read this server log and send data to Kafka, and then Proton will read the logs from the Kafka topic. and we have an initial stream work here. We actually create the external stream. This is the SQL that we create the logs so that Proton read the logs from Kafka here. Let's take a look at this Firebase configuration. It says the Firebase configuration here is simple. It specifies the logs, which is the Proton server logs, and there's a multi-line pattern because in our case we want to make sure if there's an error happens in the stack trace, it's multi-line logs, so we can process these multi-line logs here using these regular expressions, right? And then we can send the data to Kafka. Okay, so let me run this stack for you so then we know what happened here. So let's go to the Firebase directory, and I'm going to run docker compose up. So it will pull all the image and run the whole stack for you. Okay, and let's wait all the service be ready. So we can go to the Docker desktop to take a look at what's happening. So this is the Firebase stack. You can see all the services running. The initial stream is just create the external stream. It's done. So first, let's go to the Kafka, take a look. So this is a Kafka, which looks good. It's running. So because it's Redpanda, we can use like RPK list topic, right? Topic list. So we have one topic called logs, and we can run RPK topic consume logs. So we can see these are the data on the Proton logs, right? On the Kafka, it's actually reading the Proton server logs here. So let's go back to the Proton. So we're actually using Proton to monitor itself. So let's go to take a look at this log files. So we can cat. So yeah, let's go. Let me directly run the. We can take a look at these logs. It should be in the var logs. Let's say tail var logs. Let me take a look. Where's the log? There's var. Logs. Yeah, var log Proton server. Yeah, it's var log Proton server. Yeah, there's a server log, right? So I can tell this Proton server log. You see, these are the logs, or we are going to monitor, right? So let's start a Proton client. So let's show streams, which leads the stream we just create. So there's no streaming. Okay, so in this case, the Excel stream was not successfully created, but never mind. I can just run this script. Okay. Okay, it's created. You can see actually we create an external stream reading the data from the Kafka topic. So let's see what's inside this script. let's just run a query. When you run this query, select star from logs, you get nothing because there's new logs. It's streaming query is a little bit different than a traditional query because it's actually like a tail, right? You're running the new data. But let me add something to this. Settings seek to equals list. So by adding this seek to actually search the log from the very beginning, you see, and I get all the historical logs from this this server. So then I'm going to show you how we search the log in the real time, right? So here I'm running another. I'm running another. So I think we run another Proton CRI. So yeah, Docker. So the name should be like this is the this one. Proton. So you see, I'm running another Proton client. So because this stream is actually running the streaming query on that specific Proton server log, right? So for this new CRI, I'm generating some. I'm just select ABC, which is an invalid query, and this query will generate server logs, so server errors. So yeah, you see some error happening, and this error is now being collected by the Filebeat, and the Filebeat send this data to the Kafka, and then you see we got this error in Proton. So immediately, right, in a streaming way. So when we run this query, once there's new errors, we actually can identify this error using the Proton SQL query, right? So this is the way how we, and you can actually running more queries, like we can extract data from this raw text. We can using some Grok to identify the patterns. So anyway, with streaming query, you actually can process this data as soon as the new event comes. Okay, so let's go back to our slides. So that's the first stack I'm I just introduced. So we use Firebase, collecting data, sending to Kafka, and then we create an external streaming in Proton to read the topic from Kafka and get streaming data, right? So yeah, this is the configuration. So actually you can see we use the Firebase multi-line patterns to extract this timestamp. And this is a log event on Kafka, and this is the Proton external stream we will use, right? So then we can using the seek to seek to the earliest of the stream to get all the historical data. So and then we actually can run this like grok to get the real data, right? So okay, so let's do a quick summary of this first stack. So first we get real-time log. As soon as new event happens, it sends you data. Next, it's very flexible and scalable because we have Kafka, right? So with the Kafka, that means if your data, you have large amount of logs and that Proton cannot process, assuming, right? So actually, Kafka can be a middle layer, can cache this log, and also Kafka can decoupling your data producer and data consumer, right? So if you have multiple consumers that want to consume the same logs, right? So the Kafka can help you to provide this data to different consumers, right? So that's very convenient. But the problem of this stack is kind of complex, right? We have a Firebase, Kafka, and Proton. To do a streaming analysis, I have to introduce 3 different open source components, right? So that's kind of complex. So I'm going to simplify it by reduce some components, right? So next one, I'm going to introduce this new stack is called the Vector plus Proton, right? Vector is actually a open source data pipeline developed in using Rust. So it's very high performant, and this Vector team and Vector product has been acquired by Datadog, so it's a part of the Datadog product. But we can use Vector to collecting log and directly call the Proton ingest API and send this data to. So let's take a look at this. I'll give you some example. Okay, so let's stop this stack, and I'm going to start a new stack, the vector stack. So let's take a look at the vector stack. So vector stack, we still have Proton used to processing the logs, and we have collect vector which is used to to do the data collection jobs. And we also have this initial stream. So we create a stream, right? The logs stream. So in this case, actually the vector is calling the Proton ingest API. So that means we need to create this stream before before the ingest can work. So let's start this. Okay, let's take a look at this vector stream. Vector is running. Yeah, we have this Proton. Let's go to Proton and take a look. Proton client. Let's show streams. Okay, the log stream is there. Let me select start from logs. Nothing similarly. So, but we can add settings. Seek to, yeah, it's run earliest. Okay, you can see we get some historical logs here, right? And new logs is coming. Yeah, this is actually the error log we just we just typed some wrong earliest, so it's actually generates some error logs. So similarly, I can I can start generating running another Proton here. I can run this Docker. Proton. Yeah, and I similarly I select ABC, which is wrong, something wrong, and it will write the data to the Rust will the vector will collecting the data, and this error message is sending to Proton stream, and our query will immediately get this result. Okay. Okay, let's go back to the slides. You see, here's the vector configuration. So we have source, sink, and transformation. Actually, it's even though we simplify the Kafka, we don't need Kafka, but there's more work to do here is to transform the original log collected, and we turn it to the Proton REST API. So we do some transformations, and then we call the Proton REST API to ingest this data. And then we can just run the query and get everything, right? So this stack is simpler than the previous one. So we get real-time log stream. The Rust-based vector is a high-performance log collector. And the pipeline, we don't need Kafka, and I think the latency is probably better. But there's one problem is that we introduced the vector pipeline itself is it's kind of complex, right? We have source, transform, sinks, so and maintain this transform is not simple. So yeah, that's that's a limitation. But this is also the vector is very popular like a data collector. You can use vector, and it has good integration with the container world like Kubernetes, right? So we actually use vector to do a lot of data collection in our cloud. So this is the second option you can use. So last can be even more simpler, right? Actually, to do a real-time streaming log streaming analysis, you can just run Proton only. That means you just use Proton and directly analysis the logs in a streaming way. So let's show how we can do it. Actually, it's quite simple. We just create an external stream. Here we created a stream called the Proton error log, and we actually can do everything. Just directly read like a Proton is telling your log and give you a immediate result. Okay, let's go back to the demo. Okay, let's shut down previous stack. So the Proton only is just much simpler. You don't need Docker compose because you only have one component, that's Proton, right? So we just run this Proton. Okay, so and in the Proton, let's create this stream called the Proton Proton logs. I think you can either create this Proton log or Proton error log. They're just the same. Let's go to the Proton. Okay, and let's create this external log. The log has been created, and let's select start from this Proton log. Immediately you get all the data here, right? This is the historical data from the logs. And then what I'm going to do is similarly, I create yeah, I just run this Docker Proton client. Yeah, I log into Proton, and then I run the same command, see something wrong. You can see immediately the log result is coming, right? So it's super fast because without vector collecting, without Kafka pipeline, it gives you the best latency, right? Immediately you get the log result, right? It's this is the simplest stack I can think of. You get real-time log stream, super fast, super low latency, a very simple single binary deployment. You just run one Docker or one Proton, and you get everything, right? So the only limitation is that because in this case, the portal has to be in the same place of where's your log, right? If your log is on the server, you have to run Portal in the same server, or you mount that log to Portal where Portal is, right? So that's some limitations. Okay, let's do a summary here. So we know that log are critical for observability, and today there are a lot of log analysis tools, but most of them are building on top of search architecture. So that means it has limitation uh, because like I mentioned, the inverted index, build index take time. So your log are not immediately searchable. So we leverage some open source tools like Firebase, Vector, Kafka, and Portal. So we actually can build a real-time log stream analysis. That means in case you want to monitor something happening and take action immediately, these are the tools you can use to build your own real-time log analysis. Okay, that's it. Thank you for watching. So if you have any question, please contact me. For the Proton, you actually can visit GitHub. There's a Proton there. So this is the Proton repository. You can use Proton. It's open source. You can use it for free. And if you like it, please star or fork. And if you have any question, please contact us. My name is Gang Tao. I'm the CTO of TimePlus. Thanks for watching.